This is day 5 of coding every day until I hit 1K subs. Today I've been working on a 2-player Wordle game. It's designed to be played offline and works across Android, iOS, and the web. The idea is that one person chooses a word, anywhere from 3 to 15 letters long, and then hands the phone to the other person to guess. My girlfriend and I came up with this because we were playing Wordle on my Notes app when we ran out of things to do on a flight. Alright, spoiler alert for today's LeetCode problems. First up, I tackled closest prime numbers in range. Basically, you're given a range of numbers, and you have to find the 2 closest prime numbers within that range. If there are multiple pairs with the same minimum difference, you return the pair with the smallest first number. If there aren't at least 2 primes in the range, you return -1, -1. Here's the solution I ended up studying. I honestly didn't know how to efficiently find prime numbers, so I learned a technique called the sieve of Eratosthenes. The _sieve function creates a list where each index represents a number, and the value, true or false, indicates whether it's prime. It iterates through numbers, marking multiples of primes as not prime. The closest primes function then uses this sieve to find primes within the given range and calculates the differences to find the closest pair. The time complexity of this one is on log n, where n is the upper limit, due to using the sieve and then going through that list to pick out only the primes in between the left and right. Next, I did minimum recolors to get k consecutive black blocks. The problem gives you a string of W's and B's representing white and black blocks and an integer k. You need to find the minimum number of white blocks you have to recolor to black to get k consecutive black blocks. Here's my solution. I used a deckway, which is like a double-ended queue, to keep track of a sliding window of size k. I counted the number of white blocks within the initial window. Then, I slid the window 1 block at a time, updating the white block count and keeping track of the minimum number of recolors needed. The time complexity is on, because it just iterates and does the comparisons. The next one was smallest even multiple. This one's super simple. You're given a positive integer answer, and you need to return the smallest positive integer that's a multiple of both 2 and n. Here's the solution. If n is already even, then n is the smallest even multiple. Otherwise, if n is odd, you just multiply it by 2 to get the smallest even multiple. It's 01 since the operation's a constant time. Last but not least, find greatest common divisor of array. This problem gives you an array of numbers. You need to find the greatest common divisor of the smallest and largest numbers in that array. Here's the solution. First, I sort the array to easily find the smallest and largest numbers. Then, I iterate downwards from the smallest number. The first number that divides both the smallest and largest numbers evenly is the greatest common divisor. This algorithm is on log n. Because of the array being sorted, there is probably better solutions, but it passed all the cases. That's it for today. If you have any ideas for projects or anything you'd like to see in this series, let me know in the comments. Don't forget to like and subscribe, and if you want to help me continue making these videos, you can donate at buymeaboba.com, link in description.